All right. Did you get a paper? All right.
She said, sorry, that's one.
Yep, sign on the door. You got stuff to do. You guys need to get your act together. All right, here, take one of those. All right. Now, here we go. We got our sheet out. All right, I'm on the side that does not say number 2. So it's the side that does not say number 2. All right, what's opposite over hypotenuse? Sine. All right, let's not say sin, even though that's what it looks like. When we abbreviate it, the answer is sine. It's opposite over hypotenuse. Okay, let's take a look at that triangle. And remember, you need to know these ratios. So here's the 60, and then this is the side you're looking for. So across from the 60 is a √3. Now, that's easy to look at when you're looking at your gold sheet, but you got to have that memorized. You have to know that across from the 60 is √3. All right. What's tangent? Okay, so one option is opposite over adjacent, but what's another option?
Y over X.
Y over X is another option. Yep. So either one of those would be fine. They are both definitions of the tangent, and they are definitions that, depending on the problem, is the one that you will use. All right, what's the abbreviation for cosecant? Cosecant, CSC. Please do not say COS, because COS is the abbreviation for cosine. So we got to make sure we keep those two straight. All right, now we have a 45-45-90 triangle. You want to know this side right here, which is across from a 45. So across from a 45 is 1. Yep, gotta know those. COT is the abbreviation for cotangent. That's pretty easy. COT, cotangent. And then I got a triangle drawn. Theta here. 4, 3, and 5, and you want to know the cosine of theta. So the cosine of this angle. Now, based on where that angle is, you know this is the opposite side, and this is the adjacent side, and this, of course, is the hypotenuse, right? Hypotenuse never changes. It is what it is across from the 90. But theta is here, so this would be the opposite, and this would be the adjacent. So we got to figure out what the cosine is. Well, we remember the cosine is adjacent over hypotenuse. So toa, adjacent over hypotenuse. So the answer to that problem is 4/5. What is the reciprocal of the sine? Look at your gold sheet. What's the reciprocal of the sine? Be 1 over sine. What's 1 over sine? Or the reciprocal of the sine. Which one is that?
Cosecant.
Cosecant. Yep. The cosecant is the reciprocal of the sine. As you are memorizing these functions, you have sine, cosine, and tangent. Those are the big 3. And then you have their reciprocals. And notice, these are the reciprocal pairs right here. These are the reciprocals. Notice that each pair has one cofunction in it. Cosecant. This one has the cosine, and this one has the cotangent. So the reciprocal pairs have only one regular and one so sine, cosecant, cosine, secant, tan, cotan. All right, other side, same exact kind of questions, just more practice. So the first one on quiz number 2, you want to know what x is. So now pay attention, that's a 30, 60, 90. And with the side across from the 90, look at your gold sheet, is 2. That's exactly right. The sides are 1, root 3, and 2. So x is 2. Which function is adjacent over opposite? Which function is adjacent over opposite?
Cotangent.
Oh, come on, look at your list. This should not be hard. You got it right in front of you. Which one says adjacent over opposite?
Cotangent.
That would be cotangent. It's the reciprocal of TOA, right? TOA is opposite over adjacent. So when you put adjacent over opposite, it's going to be cotangent. All right. SEC is the abbreviation for what? SEC is secant. SEC is the abbreviation for secant. Now we got another triangle. And again, we're looking for the hypotenuse, but it's a 45, 45, 90, so the numbers are different. What is it in that triangle? Square root of 2. Very good. Very good. This is going to be root 2. Perfect. Okay, now we got another triangle. Theta's up here now. That matters because 13 is the hypotenuse, period. But because theta's up there, this side would be opposite and this side would be adjacent. Remember, adjacent means next to. And we want to know the sign. So what's the sign of that angle? Well, remember what sine is. Sine is opposite over hypotenuse. So opposite over hypotenuse would be 12 thirteenths. What function is the reciprocal of the cosecant? These are your reciprocal pairs, right?
Sine.
What's the reciprocal of the cosecant?
Sine.
Tangent. You got some very different definitions of the tangent. What's the tangent? There's actually 3. I think I got all 3 on your sheet. I do. What's the definition of the tangent? What's 1? Opposite over adjacent. If you're thinking SOHCAHTOA, TOA, opposite over adjacent. What else do we have? Y over x. Tangent is associated with slope. If you can remember that, you know it's going to be y over x, because how do you find slope? Change in y over change in x. Tangent and slope are very, very closely related. And then there's another one, I kind of squeezed it over on the side of the paper. Tangent is also sine over cosine. So tangent can be, if someone says to you, give me the definition of the tangent, you have options. All those are definitions of the tangent. And what's the abbreviation for cosine? COS. The abbreviation for cosine is COS. Okay, that's it. The rest of that practice is going to be on your own. You see what kind of problems I'm going to ask you. Make flashcards if that helps. I don't know what works for you when you're studying, but I can tell you that the longer you wait to memorize this stuff, the harder it's going to be. It's really, really easy. This trigonometry is an easy subject if you've memorized. So you really need to get that memorized. All right, get your notes out. Here we go. And start 4-1. I think I told you, but maybe I didn't. This is the first year that we've taught chapter 1 and then skipped to 4. The pre-calculus teachers, led by Mr. Knoll actually, have decided that this trigonometry is important enough that we're going to push it up a little bit in the year. We'll come back and get chapter 2 and 3. Those are your polynomials and logarithms. We'll get that. Don't worry. But we're going to do some chapter 4 first. We are going to need our graphing calculators. So if you're not yet in the habit of bringing that every day, please do. Because just like before, there are going to be problems you can't do if you don't have it. We don't need it right this instant, but by the time we get down to number 3, we will. All right, so here we go. Change the following degree measures into radian measures. Now, if I were to draw an angle on the board and ask you to measure it, you would say something like 60 degrees, right? Degrees is the unit that you are used to measuring angles in. But angles can be measured other ways. Just like if I said, how far apart are my hands, you might say, oh, 3 feet. Or you might say yard, or you might say 36 inches, right? All different units can be used. Well, with angles, the higher you go in mathematics, and pre-cal is kind of like the tipping point. Everything up to pre-cal is in degrees, and everything after pre-cal is going to be in a unit called radians. So we are kind of bridging that, where some of our work will be in degrees and some of our work will be in radians. But when I promise you in your calculus class, you're going to be dealing with radians. So what is a radian? And why is it used in mathematics? Well, it's used because it isn't arbitrary. The degree is an arbitrary unit. It's 1/360th of a revolution. Why did they make 360 degrees in a revolution? Because the Egyptians were fascinated by 6s and 12s. That's why we have 60 minutes in an hour. That's why there's 12 inches in a foot. They just loved those numbers. So lots of our stuff is based on that, but it's totally random. Radians are not. A radian is the measure of an angle. You might want to squeeze this in somewhere up there. The measure of an angle determined by striking an arc of radius length. Now, right now, that definition means nothing to you. And that's fine. It shouldn't. It's kind of a long definition. Measure of an angle determined by striking an arc of radius length. So I'm going to show you right now what it is, but we're not doing any problems with it yet. But let's say I have a circle, and the radius of the circle is 4. If I took a piece of string, radius length, so if I took a piece of string 4 units long and made an arc there, that is 1 radian. That's what it means to be a radian. Now here's the really cool thing.
So the angle's the radian?
Yep, this is 1 radian right here. 1 radian. So 1 revolution is 2 pi radians. So the conversion that you're going to use, just like in your, what do they call it, stoichiometric tree or whatever it is in chemistry class, 360 degrees is 2 pi radians. That's your equivalence right there. So a whole revolution, go all the way around the circle, there's 2 pi radians, and obviously there's 360 degrees. They're equal, they're the same thing. Now, the question says, 100 degrees is how many radians? That's the question. So I'm going to show you how I do these problems, and then if you're reading your textbook or you're talking, and maybe you have a tutor or a friend or something, they may do them differently, and I'm totally fine with it, but this makes sense to me. I know that pi radians is 180 degrees. Now wait a second, does that make sense to you? If 2 pi is 360, Does it make sense that pi is 180?
Yes.
I could say 2 pi over 360, but that's just more numbers, so I'm using a reduced fraction. So pi is the same as 180. How many is the same as 100? Pi radians is 180 degrees. That's fact. That will never change. That, you're always going to have that. The question is, how many radians are 100 degrees? Does that proportion make sense to you?
Yeah.
Does it make sense to you that that it's x over 100 and not 100 over x? Because that's the degree, right? And that's the degree. So they're in the same spot. They're in the bottom. So now I'll cross multiply. 180x equals 100 pi. And x equals 100 pi over 180. You with me? And why did I put an equals there?
Because that can be reduced.
Because that can be reduced, right? So we want to reduce it. So a lot of times when you do these, you're going to have a 0 over 0, so just get rid of those. That's like canceling 10s out. So we have 10 over 18, which would reduce to 5 pi over 9. And that's the answer to the question. So we want to know how many radians are 100 degrees. We set up a proportion, cross multiply, and divide. Let's try the next one. Negative 60. Negative 60. I'm always starting with pi over 180. That is fact. Like 12 inches is 1 foot. Or 1 centimeter, or no, I can't remember. Something's 2.54. I don't know. Anyway, pi radians is 180 degrees always. Right? What am I going to set that equal to? I'm doing problem B. X over negative 60. So negative 60 pi equals 180x. Does that reduce? Zeros will go out again. And what's 6 over 18? Negative pi over 3? 1 pi over 3? And all these answers should have pi's in them. We're not gonna put in 3.14 or anything like that. They're all gonna have pi. All right, what about 210? What's that one gonna look like? C.
Would you do pi over?
Pi over 180. That never changes.
Okay.
That stays the same. Always, always, always. That's always the same. Pi over 180 equals x over 210. So 180x equals 210 pi, and x equals 210 pi over 180. Which will reduce to 7 pi over 6. Perfect. That seems easy enough, doesn't it? So make a little notation, because it's going to be a while. It's going to be a week before almost a week before we do this again. Make a little notation on the side that you're setting up a proportion, right? And you're putting the degree measure, whatever they give you, you're putting it right there. That's how you're doing that set of problems. Because the next set now is the opposite. Now you know the radian measure, and we want to know how many degrees that is. Now, if your brains are still engaged, you actually can do this with a shortcut, because pi is how many degrees? So that's like 180 degrees right there. Pi is 180 degrees. If you're dividing that by 4, what would that be? 180 divided by 4 would be 45. So these you can shortcut if you stop. You're using the same idea. Pi is 180. So a whole pi is 180. When you divide it by 4, then you get 180 divided by 4, which is 45. So the next one says 2 pi over 3. We'll do the same thing. How much is pi? Just pi is 180. Well, but I divided it by 3, so now it's 60. But I times it by 2, so now it's 120. All hinges on this fact that pi is the same as 180 degrees. Negative pi over 6. What's that one going to be? Negative 30 degrees. How did he do that? Does everybody see it? He says, look, that's 180. That would be negative 180. Divided by 6 would be negative 30. 7 pi over 6. I already heard somebody give the answer, but let's walk through it. Pi is how much? 180. Divided by 6 is 30. Times 7 is 210 degrees. You have a calculator sitting there. You can, if you can't do that in your head, you can certainly type it in on the calculator. Let's skip over to F. What's the answer to F? 180. That's a cinch. E is a little bit problematic. What's wrong with E?
No pi.
No pi, so there, I can't just plug in 180 like I've been doing, right? So I'm going to go back and I'm going to set it by proportion. Pi over 180, and then equals, now the 2 is going to go somewhere here.
2 over x, right?
It goes on the top. Why does the 2 go on the top?
Because
It's the radian measure, right? And this is pi radians 180 degrees, and aren't I trying to figure out how many degrees that is?
Yeah.
So this time it's 2 over x. So pi x equals 360. I cross multiply. This is what you're solving for, so we're going to divide by pi. And you aren't going to like the looks of this, kids, but that's the answer to the question. 360 degrees divided by pi. That is the answer. We started with 2 radians. Does this kind of make sense to you that that would be 2 radians? How many degrees is pi? 180. So 360 divided by 180 is 2. The degrees would cancel and you'd be left with 2 radians. Good job. This is the answer. That is the degree measure right there. Alright, now we're going to get our calculators out. If you don't have one, you're going to have to lean over to your friend because you need to know how to do this. This will be a test question. You need to know how to convert these to degrees, minutes, seconds. Now, before we do it, I don't even know, we used to talk about it in geometry, but I don't know if they even do anymore. The angles are like the hours of a clock. I mean, so think of a degree. Think of a degree as being like an hour. The hour on a clock can be broken down into 60 smaller pieces called minutes, and each one of those can be broken down into 60 smaller pieces called seconds. Well, degrees are the same thing. Degrees can be broken down into 60 minutes, each of which can be broken down into 60 seconds. So when we have a decimal degree, we can convert it to 100 degrees, some minutes, and some seconds. And those are the symbols that we use. That is the minute symbol, and that is the second symbol in angle land. Okay? So here's what you do. It is super simple. Turn your calculator on. Type type the number 100.4, which is the number that you were given. All right, everybody with me? Now, you have an apps button on your calculator. Please don't press it, but find it. You find the apps button right there?
Yeah.
Notice that written above apps is angle. So we want to go into our angle menu. So second apps brings up your angle menu. Okay? Now, if you go down to number 4, it says DMS, that stands for degrees, minutes, seconds. So go down to number 4, press enter twice, and it tells you it's 100 degrees, 24 minutes, and there are no seconds for this. 0 seconds. All right, let's try the next one because that's all there is to it. We have 18.375. All right, and we want to change that into degrees, minutes, and seconds. So we're going to type 18.375. Then we're going to go into our angle menu, which is our new best friend, by the way, people. We're going to use this a lot. We love our angle menu. We go into second apps, right? And that calls up the angle menu. We're going to go down to DMS and press enter. Did you get 18.2230?
Yeah.
That is the degrees, minutes, seconds for 18.375. All right, would you try C by yourself? Negative 20.42. Don't let the negative bother you. It just means you're going to have a negative 20 degrees, some minutes and some seconds. No confusion there. It just means it's going to be negative. Did you get 2512?
Yep.
Yeah, that's not bad at all. So far, so good. Now, let's look at number 4. Because number 4 is asking you to go backwards. So in number 4, you have 132 degrees and 11 minutes. And we want to know what would the decimal be for that. Okay? So here's what we're going to do. Everybody pay attention. We're going to type in the first part of the angle. So we're going to type in 132. Just that part. Got it? Now go into your angle menu. So second apps where you were before. And remember we went down to DMS before? Well, what's the very first thing at the top? All right, press it because you want 132 degrees. So press that. So now on the screen, this is what you see, right? Then press 11 and go back into your angle menu. Click down 1 because that's the minute mark. You see what I'm talking about?
Yeah.
Press enter, and this comes up then, and then press enter. And it's 132.18 degrees. All right, we'll try another one here. 18, 12, 13. All right, so let's whatever you're typing in, let's stop so we can get through this one together. All right, we ready? So we're going to type 18 first, just 18. Then what? Second angle, and hit the degree mark. Then type 12, and then second angle, and hit the minute mark. And then, wait, type 13, but then stop. Because, I don't know, I should have had you look when we were in there. There's no second mark.
There's no second mark.
There's no second mark in the menu. So, I don't understand this at all, but there is a second mark on your calculator. It's above the plus sign. Look at your plus sign. You see the second mark down there? And on my calculator, it's green. It's going to be a different color. So I got to press my alpha button. So I got my 13 entered, and then I'm going to press alpha plus, and that puts the seconds up. And then I press enter, and it's 18.20, yep, 18.2036 degrees. So when we're going to do another, and there's one more here, we're going to do it in a minute, but when I am trying to put into my calculator degrees, minutes, and seconds, my angle menu has a degree symbol, right? My angle menu has a minute symbol. But if I want the seconds, I gotta go alpha plus to get that. All right, let's try that last one, see if you can do it. Negative 152, 1839. Negative 152.3108. Is that what you got? I rounded it off, but
Yeah.
you get that?
Yes.
All right, so moral of the story is the angle menu, which is second S, the angle menu has a DMS button if you need to change into degrees, minutes, seconds, and then it has individual degree and minute marks if you're trying to change back into a decimal. All right, so don't forget where that guy is, because you're going to want to use him. All right, per 5, here we go. This is probably the last one we get to today. This is a biggie. So we got this picture. R stands for radius. Theta is our angle. That's the name we give to angles. Theta, central angle. This is the center of the circle right here. And S, that's an S, is your arc length. I'm using S because your book does. You could call it something else if you wanted, but I'm using the same letter in case you ever look at your book. All right, now I want you to go back about 15 minutes, and I want you to look at that definition of a radian. Remember I said if I had a circle that had a radius of 4, and I struck an arc that was 4, this would be 1 radian, right? That's the definition. Well, what if I had a circle with a radius of 4, but I struck an arc that was 8?
2 radians?
2 radians.
That would be 2 radians, wouldn't it? Well, what if I had a circle with a radius of 4, and I struck an arc of a radius of 4, and I struck an arc of 2? Half a radian. That's exactly right. It'd be 1/2 or 0.5 a radian. So you already, without me doing anything, you already have discovered or have a grasp of the relationship between arc length, angle measure, and radius. If you multiply these two together, don't you get that one? If you multiply these two together, don't you get that one? If you multiply these two together, don't you get that one? Put a box around this. Arc length equals radius times radians. Put a box around that. That is a biggie. Arc length equals radius times radians. You figured that out without a formula. You didn't need a formula. You figured that out. But I've given you a formula now. All right, so the radius is 10. The theta is 2. I'm doing the first problem, and I want to know the arc length. What is it, Sam? It would be 20. Why is it 20? Because arc length equals radius times radians. So the answer is 20. He's exactly right. If I had given you a unit and said the radius was 10 inches, then the arc length would be 20 inches. The arc length unit matches the radius unit. All right, what about the next one? Use this formula. So in the next one, the arc length is 6. I don't know the radius, but theta is 1.5. So I'm going to divide 6 by 1.5. And if that freaks me out, I do have a calculator. I can type it in. And the answer to the question is?
4.
Sam.
Oh, my bad, I had it wrong. I had the wrong thing.
6 divided by 1.5. Oh, Sam. All right, next one. Arc length equals the radius times the angle. That's my formula. Radius times radians. So they tell me the arc length, I'm on problem C. They tell me the arc length is 10, the radius is 4, I want to know the angle. So what am I going to do?
10 is equal to
I'm going to divide by 4, right? So theta is going to equal 5 halves, or 2.5 radians. D, arc length equals radius times radians. Do not forget that. So what is wrong with problem D? It's in degrees, Marco. That's a problem because the formula says you gotta be in radians.
Yeah, it's in its
So we gotta change it, which is the very first thing we did. We have 30 degrees. So pi is 180. How much is 30? We have a 30-degree angle given to us, but we need it to be a radian. So if you have already forgotten, look back at part 1. The very first thing we did today was change degrees into radians, just so we can do problems like this. All right, so here we go. Cross multiply 180x equals 30 pi. I got pi over 6. Did you? Now, be careful though. You've done all that work and you're all excited, but that is not the answer. What's that?
That's your radian?
That's the radian measure that I needed to fill in. So, arc length is what I'm looking for. The radius is 10, and the radian measure is pi over 6. Now, as unbelievable as it is, some of you had to do that kind of arithmetic on your test and you missed it. Let me remind you, when you multiply fractions, 10 over 1 times pi over 6, it's straight across. So that would be 10 pi over 6, which we will reduce. 2 goes into both, so 5 pi over 3. And that is the final answer to the problem. All right, we have one more, and then I'm going to stop. All right, one more. Here it is. Theta is 90 degrees. Oh shoot, theta is 90 degrees. The arc length is 10 pi, that's good. And I need to know the radius, that's fine. but I can't put 90 degrees in my problem because I need a radian measure in my formula. That's why we memorized radius times radians. So, how am I going to change 90 degrees into radians?
Pi over 2.
Pi over 1, somebody already did it. Very good. Pi over 180 equals something over 90. So 180x equals 90 pi. What is that reduced to? Pi over 2. Let's talk about that for a minute. Does that make sense now that we did it? Does that make sense?
Yep.
Because pi is 180, right? Isn't 90 just half of that?
Yeah.
So it makes sense that it would be pi over 2. Next time you do that, you may not have to go through all that work. You may just recognize, oh, 90, that's half a pi. That's a half of 180. But anyhow, so this is our equation. 10 pi equals r times pi over 2. Oh, how do I solve that?
I mean, I can write it down here.
Divide by pi.
Okay, and that's fine. Think about dividing by pi over 2, but then you got to remember what that means. 10 pi divided by pi over 2 will be what? 10 pi times 2 over pi?
Yeah. We'll push it across, so it's...
So that's 10 pi over 1 times 2 over pi. Pi's cancel each other out, and the answer is 20. The answer is 20. Some of you, this is going to be a challenge because you're not good with your arithmetic. If I put a fraction in a problem, all of a sudden everything all goes all haywire. You've got to slow down. When we add fractions, we need a common denominator, right? But when we multiply fractions, it's straight across. And if we have to divide by a fraction, like we did here, then you end up multiplying by the reciprocal. All right? Okay, we got a couple more minutes. I'm going to do just a little bit more quick review. Stop it! Quit complaining. Math is fun.
Dad, can you tell us a story?
No, I'm not telling you a story.
Please, it's the last day before fall break.
I know it is, but I do want you all to be watching your email, though. I need all of you to be sometime later tonight. I need you all to check your email. I hope I get it all in. Your tests are graded. I haven't put them in the grade book yet, but I have some information to communicate with you. So please, please, please check your email. All right, here we go. Give me a definition for the sine of theta. What's the definition for sine? Try to do this without your sheet if you can. Opposite over hypotenuse. Now, this one should be easy because we have SOHCAHTOA. So sine is opposite over hypotenuse. Anybody know the other definition of sine? Y over R. Very, very good. All right. Tell me what x over y is. What is x over y?
Oh no, it's cosine.
Cotangent.
Cotangent.
Oh, what? Oh, because it's the opposite of the
Cotangent is x over y. What is the reciprocal of the cosine? What function is the reciprocal? The secant. Very good. The secant. CSC is the abbreviation for what?
Secant.
Tangent? Sam?
Cosecant.
This is the abbreviation for cosecant. Let's help Sam out. The abbreviation for tangent would be TA, right? Someday I will show you the joke books that a couple kids made me in the past, because in the joke books there is a trigonometry joke about a tangent on the beach, a tangent. All right, one more.
All the things
You
I
can
use.
do that one.
Okay. That's a bad
Last one.
What?
All right, I want to know the, speaking of tangents, what is the tangent of angle theta?
It's 4.
I heard somebody say 4/3, and that's right. Because this is the hypotenuse, this is the opposite, and this
I know I did. That's always what happens.
right now. Yeah, I don't know, because class is over at 1:20.
Got me there. You might as well start talking about everything.
No, I tell them the story, we're gonna do some more review. Alright, so I'm gonna, these aren't drawn to scale at all, but,
Physical curtain.
alright, so I'm gonna, you may need your sheet for this, unless you're really, really good at this point. But here's what I want you to do. No calculator, but you can use your gold sheet if you need it. I want you to look at this triangle right here and tell me what the sine of 60 degrees is. Now, obviously this is 60, so this would be the opposite side, this would be the adjacent side, and this would be the hypotenuse, right? But I didn't give you any numbers. Wait a minute. Don't we know the numbers?
Yeah, because it's 30/60.
Because it's a 30, 60, 90, we know that across from the 30 will be a 1. Across from the 60 will be a √3. And the hypotenuse is
√3/2.
So, putting that together with SOHCAHTOA, you can tell me that the sine of 60 is √3/2. Now, get your calculators out. And type sine 60 on your calculators. You're going to press sine 60. Now, it ain't going to say √3/2. It's going to give you a decimal. Is that decimal the same as √3/2?
No. No, it's not exact.
Take √3 and divide it by 2. Just type in square root 3 divided by 2. And make sure, by the way, that you're doing square root of 3. Square root of 3 divided by 2. We don't want the 2 under the radical. Did they come out the same?
Yes.
Did this give you the same decimal that did?
Did.
Yeah. You just found the sine of 60 without your calculator. Now, is anybody's not matching? What does it say when you type sine 60? Okay. When you type sine 60, it says -3?
Yes, that's what I'm sorry. Yes.
Okay, it can't. It would never say that. So,
Oh, it's a decimal. Mine's
-0.30, okay. Now, here's what I need you to do if that's what's happening to you. You need to go to mode, and you need to make sure that degrees is highlighted, because this is a degree measure. Okay, then you were finding the sine of 60 radians, which would be an entirely different problem. So if we're going to be entering degrees into our calculator, it must be set in degrees. If you're going to be entering radians, then it's okay to have it set in radians, okay? All right, so big lesson there. Pay attention to what mode you're in. All right, here we go. Try this one. I want you to tell me the tangent of 30. Let's see if we can figure out the tangent of 30 without our calculators. All right, so here's my triangle, 30, 60, 90. Here's the 30. So which side would this be? Opposite. This one would be adjacent, and this one's hypotenuse. Now, what are the sides of the 30, 60, 90? Across from the 30 is? Across from the 30 is 1.
Across the 60.
Across from the 60 is root 3. And the hypotenuse is 2. You need to memorize 30, 60, 90, 1, root 3, 2. That's how they're lined up. So, now I want the tangent. SOHCAHTOA. So, tangent is opposite over adjacent. So, opposite over adjacent would be 1 over root 3, which we have to rationalize. So, root 3 over 3. And you just did it without a calculator. Isn't that amazing? Very smart people. All right, one more. Let's do the, I'm going to get tricky. Let's do the secant of 45. All right, so first of all, 45, it doesn't matter which one you use. So if I use this one, this would be opposite and this would be adjacent. Now you're thinking, well, what do you mean it doesn't matter, Mrs. Ford? Well, since these two are the same, aren't these both going to be 1s? Yes. And then the hypotenuse is root 2. Now I'm doing secant. So what's secant? Actually, it's reciprocal of cosine. But that, Sam, is exactly the way I think of it. So I think about SOHCAHTOA. So cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So root 2 over 1 or root 2. That, my friends, is pretty exciting stuff. Good job. That is big time. All right, so anybody